Welcome dear students, we are in the series of content technology and we are discussing the flexible energy storage devices. In the flexible energy storage devices, we are discussing the textile based supercapacitors. So, in this we are discussing the substrate. So, substrate we can have various type. So, spacer yarn, that is a polyester monofilament, is chosen as it has a good reliance and does not adhere to magazine. So, ensuring the magazine material only to the outer fabric and preventing the short circuit between the two outer layers that act as a electrodes. So, EDX mapping of the TI element, which showing the magazine is evenly coated on the outer layer, but absent from the SY layer. So, presenting the compressive stress strain curve of the spacer fabric with the different SY structures offering the unique compressive characteristics and different hysteresis. So, maximum stress at the 65% compressive strain was achieved for all spacer fabric with increased spacer threading with different of distances and signifying the importance of increasing SF yarn threading for the high stiffness. You can see on the screen, this is the how we prepare the electrode. So, we see one by one, here is wearing a spacer fabric, how it is fabricated. So, outer fabric layer, that is the nylon yarn. In UNC there is a spacer yarn that is defined by SY layer and it is of the polyester fabric, and this is a variable density and the thickness. You can see there is a stretchable, it is a stretchable. So, it is the spacer fabric which is having a outer layer of the nylon and the spacer yarn of the polyester fabric. Now, in the another we just coat the magazine on the spacer fabric. So, brush coating has been done on the spacer fabric. You can see magazine coating both the side at the spacer fabric. Now, all-in-one textile supercapacitor is prepared, and that is after the gel infusion. So, you can see here conductive magazine electrode one side and another side also have the conductive magazine electrode, and in between that gel infusion has been done, and that is a gel electrolyte. You can see in between that there is a separator or there is a electrolyte. So, this is the basic structure of the textile supercapacitor. So, this diagram illustrates the fabrication process for an all-in-one textile supercapacitor by using the magazine coated spacer fabric. So, the design utilizing the unique structure of the spacer fabric to integrate power storage directly into flexible textile. So, the base material which we are using is the stretchable spacer fabric, that consisting of a outer fabric of the nylon and the spacer yarn layer of the polyester fiber that has been variable density and the thickness. Coating through the magazine. So, a brush coating method is used to apply a conductive magazine, typically coating onto the outer layer of the fabric and transforming them into the conductive electrode. Now, the integration, a gel infusion process introduces a gel electrolyte into the center of the fabric. This creates a sandwich structure where the middle layer acts as a separator and the electrolyte, while the outer layer serves as the active electrode. So, this is the one of the method of the fabrication. So, in the further the fabrication technologies, we are having a various method of the preparation of the supercapacitor in the flexible mode. So, flexible supercapacitor can be created by the various fabrication techniques. However, each technique varies depending on the integration of the active material on the substrate chosen, printing technology, ink formulation, deposition technique and the synthesis procedure. So, a conventional method of developing the electronic textile relies on the printing technology, which is based on the wet ink printing comprising that must be comprising of the conductive ink and superior electrical and physical properties. Ink based printing techniques like screen printing, inkjet printing, 3D printing are commonly used for development of the design pattern of the electrodes with the formulated ink. Another is the risk factor is going for the ink based printing technique is the relation between the ink and the substrate. So, ink should possess excellent rheological performance and should be compatible with the substrates to exhibit the superior electrochemical performance. So, the other end is that the printing techniques have control over the ink used in the production while transferring, depositing the desired pattern on the substrate. So, printing techniques must have a control over the ink and must be keep in the mind the concentration of the ink, viscosity of the ink, rheological properties of the ink for the production or the deposition or the transferring on the desired substrate or the desired development of the pattern. So, we discuss first the screen printing. So, what is the screen printing techniques? It is one of the scalable and reliable printing techniques which rely on transferring the paste in the desired pattern through a mesh screen. So, the quality of the printing depends on the viscosity, rheology of the ink and the construction of the mesh screen. Although this method minimizes the wastage of the material, as we are doing the screen printing, the small amount of material we use required for this for development of the particular structure and offer a good deposition rate with highly controlled position and the thickness. So, this method can be used to print the conductive carbonous material, and this is the more similar to the printing and artistic design on the textile in the textile industry. So, concerns for printing techniques are the ink drying out and poor resolution in printing small precise design. However, the pattern developed using the screen printing techniques are flexible, washable and retain conductivity. For roll to roll, that is R2R manufacturing, two distinct screen printer assemblies are utilized. First is the flat tipped and second is the rotary. So, by pouring the ink onto the screen and moving the squeezy across it. The flexible technique we use to transfer the ink onto the substrate underneath it through the stencil openings. So, squeezy and the ink are inserted into the tube of the rotary screen printer, which replaces a flat screen for continuous processing. So, you can see here there is a ink paste through the squeezy, it is just spreading on the substrate through the stencil, that is also the screening mask. So, now we can see easily that there is a flexible substrate that is used for the printing technology. So, we are having a printed structure on the substrates. This is very easy method. This is the screen printing. So, the image displays a schematic diagram of the screen printing process used to fabricate the electronic on the flexible substrate. What are the steps? First, the process. We use the ink. So, ink is pushed through the pattern. stencil mask onto the substrates by squeezing. In the another, the setup include a screen printer stage, flexible substrate, ink paste, stencil marks and squeezy. We are having this application in creating the electronic interconnects and electrochemical sensor. Another type you can see here, this is the rotating screen, and right hand side we are having impression cylinder, and this is a squeezy through which this is impression cylinder, and using the screening, and we are having the ink in between that. So flexible roller substrate is there on the right hand side. Through this rotating screen, it is just developed on the flexible rolled substrate. So this is another method for the development of the devices through the screen printing. So the process of rotatory screen printing, a common technique used for continuous high speed production on the flexible material. First is the rotating screen. This is a cylindrical mesh stencil that rotates continuously, so the ink or the paste is held inside the cylinder. Second is a squeezy that positions inside the rotating screen, and it applies the pressure to force the printing medium through the open area of the screen mesh. And another is the impression cylinder. This is a roller support the flexible substrate from behind and ensuring consistent contact and the pressure between the material and the rotating screen. So flexible rollable substrate, that is a material being printed on such a textile, plastic film and the paper or any flexible material, PET we can take, which moves between the screen and the impression cylinder in the roll to roll configuration. So we are having, that is the, you can see in between both, that both are in between both we are having a rolling paper or a rolling substrate, right. Now we can have the another paper which just diverts the symmetric supercapacitor by Rajendran, and who explained the symmetric supercapacitor employing CNT and the pani as active material, and they just resilient binder. So they created a freestanding serpentine interconnects and electrodes that are naturally stretchy and interdigited. So they were able to link only at a Iceland by first creating a required interconnects on a paper substrate and had been previously covered with the water soluble layer, and then transferring them onto a flat electromeric substrate. So for this they use the various printing technique. We can see here that these electrodes has been prepared. So the process of the screening graphene based conductive ink onto the textile to create a electronic component like for wearable technology or the energy storage. So first is the ink preparation. So graphene ink is mixed with the mix and prepared for printing. Another, the ink is pushed through the pattern screen using a squeezy onto a textile substrate to form the specific conducting track of the pattern. You can see here, it is very easy. We are having a pattern and through which the ink is spread, and you can see at last we are having a pattern. So this squeezy, it is spread onto the substrate. So next, annealing. The printed textile undergoes an annealing process which involves heating the material to improve the electrical conductivity and integrity of the graphene pattern. Its final product is a result is a screen printed textile with functional graphene based circuit such as supercapacitor or the sensor that we have used this. So this is the final sensor. After the annealing, we are having the final sensor, that is the electronic gadget, miniaturized electronic devices. So in the one of the Christie Jost in this paper, he just fabricated the wearable textile supercapacitor electrodes by knitting and the screen printing techniques. So knitting was utilized to integrate the capacitive material directly into the textile during the manufacturing process. So, in this work, a sheet of green wool in which the carbon staple fiber yarn was embedded and a continuous length of the carbon fiber collector were used. So, screen printing of active carbon ink is done on the CF carbon fiber electrode. So, this is one of the example where we are having a electrodes based on knitting and woven carbon fiber. So, this is a 3D simulation model and that is a magnified view of the shirt featuring a textile supercapacitor electrode embedded into a long sleeve t-shirt. You can see this is a one of the electrode that is just woven on the shirt. So, this is the simulated knit structure in displayed before the fabrics. Another method is the inkjet printing. So, this inkjet printing is another contactless deposition strategy and is a rapid patterning of the complex multifunctional layouts through the micrometer sized inject nozzle heads. Means we use the nozzle which is having the size in the micrometer through which just the ink is passed on the substrates or a particular structure is created through this inkjet printing. So, it can create the well defined features of the microstructures with high throughput. So, by inkjet printing, multifunctional active materials can be printed with a high resolution. In this ink printing, ink is used of the two-dimensional material. So, two-dimensional classes of the material which includes the graphene, magazine and the transition metal dicharconides can be printed as a layout for the flexible electronic application. So, these material due to their atomic thickness allow for high surface area, mechanical properties like flexibility and unique electronic transport behavior, allowing them to be used using the inkjet printing flexible devices. So, for the high surface area, mechanical properties like flexibility, unique electronic transport, we use the flexible inkjet techniques for the development of the flexible devices. Just like these two-dimensional material, MOS2 is another unique layered structure with the good electrochemical performance. So, an electro-hydrodynamic assisted method was adopted to prepare phase demonstrated MOS2 by dispersing it into a volatile solvent and following inkjet printing of the MSP microstructure supercapacitors with the high resolution. So, MOS2 ink prepared by mixing it in an optimized binary alcohol solvent showed no obvious phase transferring of the MOS2. You can see that this is a two-dimensional and you can see it is a porous material that is used for the microstructure. So, inkjet printing nozzle which is whose size is in the very small in the and then you can see MOS2 is just spreading and from the other side RGO graphene oxide is spreading. So, both are materials are used and these are the two-dimensional materials. So, the process of inkjet printing functional materials to create the micro supercapacitors on a flexible substrate. So, you can see here we are in the substrate and we are just printing the M.Sc. Like the process involves using the specialized ink to print the material like metallic molybdenum disulfide and reduced graphene oxide. So, inkjet printing technology used for scalable fabrication of the micro energy storage devices. Active material is the molybdenum disulfide and reduced graphene oxide that are utilized for their electronic properties. Flexible application, as these are the printing devices and designed for the flexible and wearable electronics. Direct ink writing of the multifunctional nanomaterials offer a scalable production of the flexible smart electronics. However, attaining fine resolution printing requires the solvent and surfactants, so which are used to tune the rheology or a concentration of printable ink, just to improve the conductivity and the pattern design. So, extensive research is required for the magazine that titanium carbide and has a significant attention due to its exceptional electronic conductivity. Means it just states that we choose the material according to its electronic conductivity. So, another material we have DMSO, that is dimethyl sulfoxide, DMF, dimethyl formaldehyde and ethanol have been investigated to disperse magazine, ensuring the formation of the stable dispersion. So, magazine is dispersed in the various material, and by keeping the concentration as well as keeping the rheological properties, it is prepared for the printing purpose. So, micro supercapacitors and another design on the flexible substrate designed by using this ink with the water molecules on the top panel are the formulated with the extrusion printing. So, to prevent re-aggregation, the organic ink must be sealed in organ-filled hermetic bottles and that kept in the refrigerator during the formation of the magazine ink. You can see here there are the various ink has been formed. You can see there is a aqueous magazine ink and there is a that is defined in the blue, and there is a organic magazine ink, means the solvent which you are using the different. In the upper one we are using the water solvent, so water molecules, and in the lower one we use the different solvent. So, direct magazine ink printing has been done. So, you can see inject printing, upside and lower side there is a flexible substrate, and through this nozzle the printing is done by using the printer. So, we fill this ink into the printer and then the particular pattern can be designed on the flexible substrate. So, direct magazine ink printing has been done. So, in this direct printing of various metal oxide ink onto the bamboo fabric substrates is also used. One of the paper defined by the Poonam, and that explain the direct printing of the various metal oxide inks onto the bamboo fabric substrate. So, they engineered the symmetric MSV microstructure supercapacitor utilizing the MnO2 nickel CO2O4 as a positive electrode and RgO as a negative electrode and LiClPVA as a gel electrolyte. So, MnO2 and NiCO2O4 are renowned pseudo capacitive material widely recognized for their profs in the energy storage application. So, inkjet printing emerged as a swift and scalable approach for crafting microstructures on diverse flexible substrates and including textiles. However, they impose some limitations when preparing the ink, including the rigid physical properties, post-treatment processes and maintaining rheological properties to dissolve the nanomaterial in the proper non-toxic solvents. Improper adhesion of the ink over the substrates may diminish the electrochemical performances. So, the physical property of the ink including the viscosity, surface tension and the density, which are carefully studied for development of the microstructure supercapacitors. Another challenge is to filter the ink through the 450 nanometer filter to remove the large particles, which may clog the nozzle of the printer. So, the smooth flow of the ink should be through the nozzle. The quality of the print depends on the another crucial factor, which is the surface of the substrates. The ink contact angle with the substrate should be 0, so that the ink gets absorbed on the fabric or the textile. So, there is a problems of spreading of the ink on the substrate, there will be a wastage of the material and the quality of the printing diminishes. So, the textile serves both as a current collector and the electrodes for the supercapacitor utilization. So, at a high density, we require significant capacitance, we require development device exhibit excellent electrochemical efficiency. So, when after the many cycles, it must retains its capacitance and reaches a peak power density. So, this is one of the printing technology, ink printing method that is used for development of the flexible supercapacitors. Further, we will discuss another methods which are used for development of flexible supercapacitors. Thank you very much.